Lesson 4.2, we're going to be talking about the standard form of a quadratic function. The standard form of a quadratic equation is f of x equaling ax squared plus bx plus c. You can find information about the graph of a quadratic function, such as the vertex, easily from vertex form. Vertex form is what we talked about primarily in 4.1. Such information is hidden in standard form, though. In standard form, it's easier to enter into a graphing calculator. All right. We won't be entering it into a graphing calculator in this lesson, but what we're going to do is by hand solve for the vertex, the axis of symmetry, and then find minimum or maximum values. So we're not going to use the calculator, we're going to do it by hand. Alright, so problem 1. What's the vertex, the axis of symmetry, the maximum or minimum value, and the range of y equals 2x squared plus 8x minus 2? Alright, we're going to first find the vertex and the axis of symmetry, and we're going to use these steps here to do so. Alright, so the first thing you want to do is write down what your A is, what your B is, and what your C is. So your A is the coefficient in front of the x squared term. So that's going to be 2. Your B is the coefficient in front of your x term. That's 8. And your C is it's the constant at the end, so negative 2. Alright, so to find the vertex from an equation written in standard form, the x-coordinate of that vertex is going to be equal to negative b over 2a. So x equals, alright, negative, and then what's my b? My b is 8 over 2 times my a is 2. So I have negative 8 over 2 times 2, which is 4. A negative 8 divided by 4 gives us a negative 2. So the x-coordinate of the vertex is negative 2. Now to find the y-coordinate of the vertex, we're going to plug x back into the function and solve. So y is going to equal 2 times, and everywhere I see x, here and here, I'm going to plug in negative 2. So y equals, order of operations, we do our exponents first, so negative 2 squared, that's going to give us a positive 4, times 2 is 8. 8 times negative 2 is a negative 16 minus 2. Alright, so I have a negative 18, combine this, so you have an 8 minus 16, that's a negative 8, minus 2, that's a negative 10. Okay, so the vertex is going to be found at the ordered pair negative 2, negative 10. Alright, the axis of symmetry, it's a vertical line through your x-coordinate of the vertex. So your axis of symmetry is x equaling the x-coordinate of your vertex is negative 2. Alright, and then we have to determine if this is what the minimum or maximum value is. So if we just sketch a quick sketch of the graph, our vertex is at -2, -10. Let's just down here. So it's -10. This is -2. Okay, so -2, -10 is where the vertex is at. Here's the axis of symmetry. Now our A. Our A is a +2. Okay, because it's positive, our graph is going to open up. All right, because it opens up, that point right there, the vertex, is a minimum value. So we have a minimum. Don't ask, this is why I'm writing in pink. So we have a minimum value. What's the y coordinate of that vertex? It's -10. Alright, and then your range, it's all possible values of y. So if I start down at -infinity, the graph is not there. The graph does not start with relation to the y-axis until -10. So my range is your y has to be greater than or equal to -10. Now there's one more thing that I want to point out. In these quadratic equations, your constant, so in this case -2, that is also what your y-intercept is. So notice that this graph would cross somewhere right in there. Well, that point would be -2. Okay, so that's another key point, key piece of information that we can pull from these quadratic equations written in standard form. Alright, in problem 2, now we're going to graph the equation y equals x squared plus 2x plus 3. And so in order to do that, we will need the vertex. Oops, let's erase that. So let's find the vertex first. So this is in standard form. So the x coordinate of the vertex equals -b all over 2a. Alright, so we're finding the vertex. So x equals, well, my a is equal to 1. Remember, that's the coefficient in front of your x squared term. There's nothing there, so it's 1. Your b is the coefficient in front of the x, that's 2. And then the c is your constant, that's 3. So plug in. So we have negative, and then our b is 2, all over 2 times 1. So x equals, I'm going to need some space, so, oops. So we have -2 divided by 2. That's going to be -1. Now to find the y coordinate of the vertex, we're going to plug in -1 into our equation. So y equals, remember, whenever we plug in a negative, let's put it in parentheses. So -1 squared plus 2 times -1 plus 3. So y equals -1 squared. That's going to be a positive 1. 2 times -1 is -2 plus 3. So that's going to equal 2. 1 minus 2, that's negative 1, plus 3 is a positive 2. So our vertex is the ordered pair. Negative 1 is the x-coordinate, and 2 is the y-coordinate. The axis of symmetry, it's going to be x equaling the vertex, the x-coordinate of the vertex, so negative 1. Alright, so let's take those two pieces of information, the vertex, negative 1, 2. And then the axis of symmetry is x equals negative 1. Okay. Now, since we're graphing this, we want our graph to be as accurate as possible. So we're gonna remember in 4.1 we try and get 2 points, graph 2 points to the right and 2 points to the left. So let's go 2 points to the right. Let's graph 2 points to the right. So what we know here is, remember I was saying our c, or our constant, that's our y-intercept. So we know that this graph is going to cross the y-axis at 3. So we know 0, 3 is a point. So if we know 0, 3 is a point, we can reflect across the axis of symmetry, and we know that negative 2, 3 is a point. Okay, and then to find the second point, we can plug in 1 into our equation. So y equals 1 squared plus 2 times 1 plus 3. So y equals 1 plus 2 plus 3, so y equals 6. So 1 comma 6 is a point. And if we know 1 comma 6 is a point, we go 2 units to the line of reflection and 2 past, so we know negative 1, 2, 3, it looks like negative 3, 6 is also a point. And then we connect. Okay. We're not asked this, but the minimum, we have a minimum because this opens up. And again, it should open up because our A is positive. So our A was positive 1, so it opens up. And so we have a minimum, and the minimum occurs at the y-coordinate of the vertex. So the y-coordinate of our vertex is 2. So a minimum value of 2. And then if we were asked what is the range would be y having to be greater than or equal to 2. Okay, there's no y coordinates down there. There's no y coordinates below 2. They're all the y coordinates on this graph are above. So the range would be y greater than or equal to 2. Okay, in problem 4, we got an application problem. The New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. You can model the arch with the function, and then you have it there, where x and y are in feet. How high above the river is the arch, and how long is the section of bridge over the arch? Alright, so the first thing we want to do is find the vertex of this arch. So we want to find that point right there. And what you see I highlighted in yellow, I just drew a graph over here to the right. So we want us to find that point right there, which is the vertex of our parabola of our quadratic equation. So to find the vertex, we need to write down what our A, B, and C are from our equation here, right there. Alright, so our A is negative 0.0000498, and then our B is 0.847, and our C is 0. So this is in standard form. To find the vertex, what do we have to do? We have to write x equaling, so vertex x equals negative b over 2a. So negative b, so negative, and then our b is 0.847 all over 2 times negative 0.000498. Alright, plug this into your calculator and you're going to approximately get 850. Alright, so that's the x-coordinate of the vertex. Now to find the y-coordinate, we're going to plug in 850 into our equation everywhere we see x. So there you go. Alright, we have to enter this into the calculator, and when we do so, we get approximately 360. Okay. So, the first thing we have to answer, how high above the river is the arch? So from here, so this distance right here is 360 feet. Right there. So that's 360 feet. But it asks how high above the river is the arch. So we have to add in that 516. So 360 plus 516, and we get approximately 876 feet above the river. Okay. Now, how long is the section of bridge above the arch? Alright, so in purple, there's the section of bridge above the arch. How long is that? Well, we know that the axis of symmetry is the x-coordinate, is the vertical line, x equaling 850. So, and what this axis of symmetry does, it basically cuts the parabola in half. So this distance right here is the same as this distance right here. So the total distance is going to be what? Well, we know that this distance right here is 850 feet, because that's our vertex. The x-coordinate So we go over 850 and then up 360. So this distance right here is 850. Well, add another 850 and you're going to get the total length of the bridge above the arch. So 850 plus 850, that's going to equal 1,700, and we're in feet. So 1,700, so we have a 1,700 foot long bridge over the arch. We can just leave it like that. Okay. Alright, so that wraps up 4.2.